Now what about this series, sum from n equals 0 to infinity of n factorial x to the n? So what I notice about this one is there's no fraction involved. Nothing's going to 0. In fact, these terms are going to infinity. As n approaches infinity, this n factorial is going very rapidly to infinity, and x to the n is going to infinity exponentially. So it looks like this series diverges by the nth term test, and in fact it does diverge by nth term test. It diverges by the nth term test. It diverges by nth term test. But wait, unless the x is 0, unless x equals 0, because then you would have 0 to the n every time you do n factorial times 0, you'd be adding up 0 plus 0 plus 0, it would converge to 0. So this series diverges for all values of x. It diverges for all values unless x equals 0. So that means the interval of convergence isn't really an interval at all. It's a set. It only converges for the value x equals 0. And the radius of convergence is 0. So what we've seen is examples of basically the three different things. There are three different things that can happen with a power series. So we're going to say that the power series centered at A, where A is any real number, and that power series is sum from n equals 0 to infinity of c sub n x minus a to the nth power. Either, all right, it does one of the following three things. It either converges only at x equals a. And that's what we really have here. The center of convergence was 0. So when x equals a, this term is 0. So that's what we had here, something that converges only when we get zeros there. Or it converges for all x. That's what happened in our previous example. Or the series converges on an interval x as an element of the interval a minus r to a plus r. Right? So we have a certain center A, and we're subtracting r, and we're adding r, and developing an interval of a certain radius. If you think this was a circle, an interval of a certain radius that way. Where r is a real number, which is called the radius of convergence. Now, it's a note that here we're saying that the series converges definitely within the interval, but we're not saying anything about the endpoints, because such a series may or may not converge at either endpoint of the interval. And so you have to test each endpoint separately. We'll see examples of that. All right, so this is a theorem that we have actually in the book. I forget what page it is, but you should read this section and find that theorem. So I'm going to tell you what the homework is, and then I'm going to do one more video where I'm going to, I'll do one of the homework-related problems. So the homework on this section is page 717. So I want to keep these light so we can really look at them carefully. We're going to do number 12 through 18, even. My God, I'm assigning the even problems for the first time ever. And also you get number 25.